Hello YouTube, it's Friday, January 27th. Thought I'd make another video, sort of like a catch-all. It started out with the old heavy mass object I was looking at. I went ahead and made this up a while back and thought I'd put it on a video. But we started out with the object here with the L in an orbit and changed it around to where it lined up with the Earth and the Sun on the March 11th. And also changed the timeline to where it would cross the Earth's orbit at about December 21st, 2012. And you got it going there, and you can see it passing through. And note that it passed Saturn back here a ways back in 2010. And crossing Jupiter's orbit. And I got it set to where it reaches right about in here on December 21st. And as it goes through there, it's basically the same orbit as Allen was on, with just a couple tweaks. Had to tweak the paracenter just a little bit to get it to where it lined up. If we go into the other view here, this is 3:11, 10 o'clock Universal Time, 2011, and you see it lines up fairly well with the Earth on that date. So let's go back and see what it looked like on, say, 2/27/2010. Okay, on that date, we can see that it doesn't line up where it lined up perfectly well on the other one. It doesn't line up here. And if you take and run it ahead there, you can see that even though it lined up perfectly on 3/11/2011, it does not line up back here. Back here it would have had to have been 3/6/2010 to line up instead of 2/27. And we can advance that ahead and look at the upcoming date also. And if we do that, that would be 22. And as you see, it's almost lined up right there. Getting close. It's just a few hours off there. But when you start backing it up in time, it just doesn't match up. So the orbit don't work out all that well for a heavy mass object coming in there. You see it would actually be just a little bit over into the 22nd there, even though back here it lined up perfectly. So that was one thing I looked at, and also, if you remember, a while back we made a couple videos here about putting a heavy mass object out there and having it come through the system to see what happened. And as you saw, nothing good happened at all. I used 3 different ones, and they were all the same. It was total chaos in the system, just outrageous stuff going on. Planets being kicked out, planets being stolen. It's just one thing after another. And went ahead and made another one because some people were saying, well, what happened after a while? And well, what happened after a while was that it never got better. It progressively got worse, and basically ended up destroying everything in the inner system. And so I made another one up, and made it a little bit smaller. The smallest one I had on there was, I think, 0.07 solar mass. This is 32 mass Jupiter, 32 times the mass of Jupiter. And you can run it ahead there, and this is basically the same one that was on Starry Night. I adjusted it to where it lined up with the Sun and the Earth and the HMO all lined up on 3/11, and adjusted it to where it crossed right about the Earth's orbit at 12/21/2012. And as you see it come in, you see the same thing going on. You see that if there were anything out there, if there was anything out there, you would see Saturn's orbit deteriorate. And it would have happened a while back. We're starting again from the same as the other videos on this program. It starts at 2000, so add this to 2000 and you get the date So this would be 2007, right about there, and you'd see Saturn's orbit start to deteriorate shortly thereafter. And that would have been noticeable to anyone with a telescope and a go-to telescope. As you see, there goes the orbit right there, shrinking down and going all out of whack. This is back in 2010. Of course, that didn't happen, so kind of leaves you with the impression that there's nothing out there. So as it comes through again here, we'll slow it down. And you see it taking over Mars' orbit here and pulling it around. And there goes Mercury's orbit and da-de-da-de-da. And it just basically messes up everything in the system. And there goes Mercury's really getting dragged around there. And now it's going after the Earth. There goes the Earth's orbit. So it gets shifted all around and it's dragging Mercury around again. So that was the first pass through, and as before, it messed everything up and it didn't come back. In other words, it just kept going on. And with this version, it actually got worse because you see it going out here, and when it got to Jupiter right there, you saw it come back with the orbit there, and if you look at it, all of a sudden it's a closed orbit, and it's a close orbit. So what happens when it passed Jupiter this time on this timeline is it kicked Jupiter out. Jupiter's gone, it's going out. So we lost Jupiter on the first pass here, and the HMO is now on a closed orbit, a close closed orbit, and it will be back. And we can take and run that ahead here and see it go on out and come back around. And on its second pass through, we can see what happened to it. This thing doesn't like to get advanced, so you got to skip by it. And we'll skip by it there and see what happened on the inside here. Okay, so now we've got a lot of things thrown around. Mercury's over here, the Earth and Venus there, Mars is still there. So we basically still have all the system, all the inner system planets there. And you see Saturn's out here now with a really strange orbit. And of course, Jupiter got tossed the first time. So the second time we get by without any major disruptions. Then we go on ahead for the third pass, and here we go. So we're missing another planet, missing Venus. Venus got tossed that time. See if we can see where Venus is. Yeah, there's Venus out there. And a heavy mass object's going to make another pass. So first time we lost Jupiter, next time was just messing up things. Then we lost Venus, and we can go on around to the next pass. And on the next pass, I think that's this pass. Yeah, this is the pass. You lose Earth on this pass. So just about every time it comes through, it tosses a planet out. And that's common with a binary system. Binary systems are not conducive to planet formation. And you see the reason right there. It just doesn't work. Some planets and some binaries are possible if it's a wide binary. But a close binary is extremely difficult for planets to survive. And we've seen that over and over again. So there's basically no way that you can have the nice, neat system we have right now if there was anything out there coming through on a regular basis. It just doesn't work. It would be total chaos in here, and it's not total chaos, and so you can pretty much be assured that there's nothing large coming through here on a regular basis or coming through here even once, because you would not have these planets out here. Even on a wider binary, you would not have the outer planets in such a neat circular orbit. It just doesn't work. And we can go back and look at a few of the other papers here people have been talking about. On this one here, this is one of the professors in Louisiana that's talking about how Tyche may be out there. Well, he hasn't seen Tyche. No one's seen Tyche. The only thing he's come up with is because comets are being diverted in a certain pattern, and he's theorizing that because the comets are being thrown this way, then it's statistically possible that they're being thrown by a large object. So he's got this theory up here that maybe something out there about 10,000 to 30,000 AU. Hello, that's half a light year, 30,000 AU. So it's way out there, and he doesn't even have any evidence of its existence except for the comets being thrown around the way they are. In other words, nothing's been cited, but yet there's post after post after post citing this guy's work, saying that he has cited Tyche. And you look at his paperwork, and he hasn't cited anything. This is the last paper that he had right here. I've already got it loaded. This is from 2011, October, in France. And he goes through talking about it here, and gives you about where the great circle is of the comets that are being disrupted, and da-de-da-de-da. And he's come up with 4 possibilities. Well, in this paper here, this is the last one that he has listed on his site. He has 4 possibilities here. It turned out that one of them is a dwarf that's out 350,000 AU. Actually, it's 1.7 parsecs, or 5.5 light years away. This one turned out to be something. The other ones he's got here, one at 30,000, which is half a light year, 40 and 40, which is over half a light year. It's turned out that those are probably extragalactic, meaning they're not in the solar system or even close to the solar system. So he's got the conclusions down here, and he was thinking that those 3 may be one mass Jupiter bound objects, and now he thinks it's possibly extragalactic. So it's turned out to be nothing. The only thing that he did identify was the one brown dwarf out at 1.7 parsecs, or 5.5 light years. So there's nothing here in his work that indicates there's been anything found out there, but yet people keep pointing to his work and saying that Tyche has been found when it hasn't. Now, he keeps talking about WISE. The full release is going to be in March. Finally, here in March, we can look at the WISE data. You see, we've got everything down here available in March. And we can look around and see if there's anything out there. But at this point, he thinks that the 3 remaining candidates are probably not in the solar system. Okay, so we go on this other one here, and this Lorenzo Iorio. Remember this guy? Yeah, that's right. It's the same guy that made this paper up here about the moon's orbit that everyone jumped on, saying it was proof that the moon was out. Well, if you read the paper, it said that there's no way it could be caused by any planet-sized body, because it would have to be closer than it's possible to be to cause the anomaly with the moon. And if you look here, the first paper came out in February, 1st February, the first release of this paper on the moon. Well, if you go back and look at this paper, this was released in 13 January, about 2 weeks before the moon paper. It has 3 releases here in January. And he's saying right here that looking at the planets with independent group of astronomers, I think that's the way he put it here, they've come up with saying that there's no possible way that a planet the mass of Mars could be closer than 150 to 200 AU. If it had 0.7 the mass of Earth, it would have to be at least 250 to 450 AU away. And if it was 4 mass Jupiter, it would have to be 3,500 to 4,500 away. This came out in January of 2011, a couple weeks before the moon paper. But people weren't looking at this. They were looking at the moon paper trying to say, there's something close. This guy says it. No, this guy says that if it's a size or mass of Mars, it would have to be 150 times farther away than the sun. That's what he was saying. In the other paper, the moon paper, he just said that it's impossible because the planet would have to be close to do that, and there's nothing close because his other paper proved it. So it's just people not understanding papers is all I can say. And we go back to this paper here. This is one of my favorites here. Talking about how people think that most stars are binary. Well, as it turns out, most large stars are binary. In fact, they did a study and they found out that most of the red dwarfs are singular. They're not binary. And most of the planets in the system are red dwarfs, or most of the stars in the system are red dwarfs. So your larger stars are 80% of the larger stars are believed to be multiple, but they're rare. You have 25% of the red dwarfs have only 25% of the red dwarfs have companions. So you combine that with the fact that 85% of all stars in the Milky Way are red dwarfs, and you got 2/3 of the stars in the galaxy being singular, not binary. This came out in 2006. Okay, so you go on and you read it through there, and there's one thing that you notice here. He's not mentioning brown dwarfs. He's just mentioning red dwarfs. Well, we know that brown dwarfs are starting to get real popular, and if you look at this paper over here, you see they say that free-floating planets, Jupiter-sized planets, are probably as common as stars out there. Well, all you got to do is jack up a Jupiter mass to 13 times the Jupiter, and you have a brown dwarf, which is a star. So we've got as many brown dwarfs out there as you have stars, probably more, free floating, and they would probably, a good number of them, be considered stars, and they are free floating, meaning they're not binary. So if you throw the free floating brown dwarfs from this article in with the 85% of the red dwarfs in this article, you're going to have a lot of single stars out there. Very many more than binary stars. And you go ahead from there, and yeah, brown dwarfs are hard to find because they don't put out any light. That's why they're hard to find when they're far away. When they're far away, they don't put out any light, and they are hard to find because there's nothing to reflect light off of them. But if you get it close to the central star, it reflects light just fine. There's no problem with it. And if you look at Sedna and the other planets out in the Kuiper Belt and out in the scattered disks, they're just as cold as the almost absolute zero, close to about 12 degrees. And they reflect light just fine. So I don't know where people keep coming up with this stuff about brown dwarfs don't reflect light. If you look for a paper, I cannot find a single paper that says brown dwarfs do not reflect light. What I find is a lot of papers saying that when they're out there by themselves with nothing to light them up, they're really hard to see because they don't put out any light. But if they get close to a central star, they reflect light just fine. And there's nothing around on these the images that they show you of artist's conception of a brown dwarf. There's not a single thing that says, oh, excuse me, but if it's really cold, you can't see it. No, there's nothing like that around. It gives you the picture of the brown dwarf, and that's it. In other words, there's no thing saying that if it's so cold you can't see it. Nothing there at all. So sorry about that. All right, so we go on from there, and okay, the north orientation of the planet. And people keep talking about these earthquakes that change the orientation of the planet. And if you look right here, this is a French site. They're one of the people that do the Earth orientation. And they're telling you that the amount that was theoretically changed by the earthquakes is so small that you can't tell it apart from the daily changes that happen with the winds and the tides and so forth. So such a step could be hardly discernible from common hydrometeorological processes that happen every day. And if you go down and look at the Chile one, it's the same thing. Down here, earthquake in Chile 8.8 has caused no detectable effect on the rotational pole and the rotation rate. Independently of earthquake, rotation pole moves of some millimeters up to several centimeters per day because of continuous atmospheric, oceanic, and hydrological mass transport. Till now, the effect of the earthquake remains a theoretical matter. According to seismic models, the recent Chile earthquake would have had an effect of disturbing the rotational pole by 8 centimeters in some months, a small amount in comparison to the path of a few meters it would achieve during this period. So people that keep talking about the earthquake changed rotation axis, it changes much more every day, and there's no way to tell just how far an earthquake did it without using your calculator. It's a theoretical matter, and the thing changes. Up here it says there's a mean by handling atmospheric, oceanic, and hydrological data, the path would be modeled after a mean error of 50 centimeters, so that tiny seismic effect would probably remain undiscernible. And it's just, you can keep on saying that to people that don't know any better, but some of us know better. Hopefully some people will look at this and they'll have a better idea of what's going on. And if you want to take and go in through here, you can look up what the pole has been doing over the last few years. Just change that to there, set your date there, submit request there, and there you have it for the last 10 years. And here we have it right here on December 27th, 2011. The Earth's center was right there, which is closer than it has been in recent years. So the Earth's wobble is actually getting less. And not only that, but if you check out the magnetic pole is moving closer to the geographic pole also, so that's better than it's been in the last few years. It's just one thing after another. Another one's this cloud people keep talking about. Okay, 30 light years across. It looks like the solar system is thought to have entered a local interstellar cloud between 44,000 and 150,000 years ago, expected to remain for another 10 to 20,000 years. We've been in this thing for 100,000 years. All of a sudden people are worried about it? I'd be more worried about when you got out of it myself, but whatever. But so what does this look like? Well, if you click on the picture down here, astronomy picture of the day, you get that. Okay, so that's the local interstellar cloud. That's the same one the article's talking about. We've been in it for 100,000 years, and it says our sun may exit during the next 10,000 years. This is the same picture at Wikipedia, and this is at NASA. It's the same cloud, same picture. You can look at it right there, and astronomy picture of the day. Same picture. Alright, so you go on from there, and okay, so we've been in it for 100,000 years, and it hadn't caused any problems yet. Why are we so worried about it now? And we go on ahead and we find another article. This is an old article, University of Chicago, and they say, well, yeah, we're going to enter another one, but it's not going to happen for another 50,000 years, so I'm not going to worry about that one. And we go over here, and this is an article a lot of people point out. Interstellar discovery, tilted magnetic field, da-di-da-di-da. It's the same picture, people. It's the same picture from Wikipedia, from NASA, talking about the interstellar medium. It's the one that we entered 100,000 years ago, and we're going to be in it for another at least 10 to 20. It's the same picture. It's the same cloud they're talking about. And not only that, but if you take and you go ahead from there, and you say, okay, this was December 23rd, 2009. Let's go ahead one more step here. Mystery of the giant ribbon solved. Oh, the ribbon. Okay. So this is January 2010 here. And they found the ribbon here that they're all worried about. And they found out that, hey, if you put in a model of a reflection, it looks exactly like the ribbon. So the ribbon that everyone was freaking out about is just a reflection off of where the magnetic field, the same picture again over here, same picture, where the magnetic field is interacting with the galactic field. It's the same picture over and over again. Same field they're talking about. Okay, so we go on one more step. Yeah, where do those reflections come from? Well, there's bubbles out there. And so all the stuff that's been going on out there about magnetic fields and fluff clouds and everything else, this article right there just threw all that out. It's like the spacecraft is in an area where there's a bunch of bubbles. They keep flying through these bubbles. The magnetic field changes in each bubble, and they don't know what's going on. It's way out there, and they're scratching their heads about it. But you can take all the stuff about the last articles back here and basically throw them away. What Voyager found was a bubble, a big bubble, same cloud, big bubble. So now they're flying through bubbles, and they still haven't figured out how that relates. And this was the last article on the Voyagers out there, and this was in the middle of 2011. So this fluff cloud that everyone keeps talking about, it's the same picture in all these articles. Same picture. So we've been in it for 100,000 years, people. It hasn't hurt us yet. Why are you worried about it now? 100,000 years ago, 44,000 to 150,000 years, we're going to remain in it for another 100 or 10,000 to 20,000 years. Nothing going on there either. Alright, so I'm going to call it an end, and talk to you next time.